I'm bringing back STL Sunday. What's going on, everyone? Today, I'm bringing back STL Sunday. And if you're not familiar with what that show was, it's when I used to design live in Fusion 360, as it used to be called, just Autodesk Fusion, as it's called now. And I would go through a project live and kind of design it up, showing you what I was doing. And today, I want to try and bring that show back, but in an edited format, and see if it performs any better. So today, we're going to tackle a project that I've been just needing to tackle for myself. This is my Futaba 10PX, and I want to put a different wheel on here, and one that is not made to just mount up to this radio. So I need to make an adapter to allow me to take one of my Vanquish 1.9 wheels and adapt it onto this radio. We've got a blank Fusion document open, and I have my radio here in hand. Now, I'm going to show you, to the best of my ability, both what I'm doing on screen and here in front of me. Obviously, what we need to do is we need to take the wheel off of the radio, and we need to model up what the backside of this radio looks like, and then we need to model up this wheel itself. So with the wheel off, we don't need to get crazy, but we need to make sure that we're kind of taking into account where everything is going to be a problem. I can just lay it over top of it and see how everything is going to line up and see what kind of restrictions that I'm going to have. And it actually looks pretty much ideal to just put it right where you would think. It's not going to have to stand off. It's going to be a pretty easy and pretty simple design, I believe. So we don't really need to worry about anything beyond the face of the radio. So I think I'm just going to start by taking a couple of basic measurements just for reference, and then we'll build from there. I'm going to take my calipers and take an outside diameter. This is non-critical, but we're going to go with 49. First thing that we're going to do is we're going to hit the sketch at the very top. Then we need to select a plane. Now I'm going to use Shift and click of my center wheel on my mouse to rotate around. It's just going to be a habit that I'm going to do frequently. I'm going to select the front plane. You could select any plane. That is completely non-critical. From there, we're going to hit C for circle. I'm going to select the origin point just to give us a solid base to start from. Drag out, and then I'm going to type 49 and hit enter. That gives me the base there. Now, from here, we could start designing up those center portions, or just to give you a quick, easy idea of visualizing, we can hit E for extrude, select that inner pocket, and we can just drag this back. Now, again, we're not really concerned about the depth, but let's just grab 13.5 millimeters and hit enter again. Again, we're going to go up. We're going to hit sketch again. We're just going to select the face of that circle. And now here we're going to design the next boss that is part of this. So again, we're going to take a measurement. Now this has a slight draft. We don't actually probably need to worry about that yet. So we're just going to take that at 21.2 roughly. Hit C for circle again. On the origin, 21.2. E for extrude. Select that center. We're going to use our calipers to gauge the height at 4.46. Sketch again, on the face again, and we're going to hit a circle, C for circle, and we can just drag out. We don't have to know the diameter right away. Let's just drag it and drop. That's the wrong measurement, but we're doing that on purpose. Now, I'm going to do the center portion of this wheel here, and that is at 7.85 millimeters. So now we're going to hit D for dimension, select that circle. We can pull this anywhere and type 7.85. And now we have the full circle. But this is not a full circle. It's actually it's got a flat spot on the bottom, which is, you can see there. So I'm going to measure from the outside to that flat, and that gives us 6.6. So I'm going to do L for line. We're just going to select 2 points. Then I'm going to grab the center point. Now, there's a triangle that pops up. It's hard to see there, but the triangle that pops up lets us know that this is in the center. So I'm just going to drag up, and I'm going to purposefully not cross over that center point just for a visualization on this part. Now I'm going to hit the coincident mate up here. And this just means that two things need to be touching. You're forcing those two items to touch. So we're going to select that line and then the center point. And now that makes sure that that line crosses the center point. Now that line that we selected there, that's just a line that I want to make sure is there for measuring, not one that I actually want to build something from, which will make more sense as you get more comfortable. But you can go over here, this line type, and hit construction, and that uses it as a dashed line. You can also toggle that by selecting the line and hitting X. That'll turn it back. It'll just go one way or another. So X for construction is super helpful. Now I'm going to hit D for dimension again, pull off from there, and we want to make sure that we're going so that it's in the way that we measured it, not this way. That doesn't have really any reference to anything that we did. So we're going down and we're going to type 6.6. Now this line is blue still. You really don't ever want blue lines. You want all your lines to always be black. That means that they're fully defined and they can't be moved, because right now this angle isn't set and we can just drag it around in any way. So as I mentioned, this isn't critical, the orientation of that, because this whole piece here can be rotated on this radio. So we're just going to say that it's flat, and I'm going to click this horizontal vertical constraint up top and then select that line. We're going to select that line and then I'll hit the constraint. So now everything is black. That means it's fully constrained. One other thing that we're going to do while we're here is I'm going to hit C for circle, and I'm going to put that center bore in where the screw actually goes into the radio, 2.6. That's usually the dimension for an M3 threaded hole that I'll use, at least in 3D print, even though we're not printing this part, but you'll get the point. Now, again, we've got our geometry done there. I'm going to hit E for extrude, and we're just going to select that portion. And now we can drag that arrow up. We can drag it up to any dimension. It doesn't matter at this point, but I'm going to measure 7.8 is what we get. So we're going to type 7.8 and hit enter. So now we've got that portion. Now we have this other feature here at the bottom, and that is like the steering stop or the angle stop for the actual wheel. And the wheel that we took off has a pattern that interacts with that, and we're going to need to recreate that on our new one. We're going to do a sketch again. We're going to select that plane again. I'm going to create 2 circles to start with. I'm going to measure the distance from one to the next. We're going to say that the distance between those two is 2.9. We're going to try and just pull off of a dimension that we can get a hard measurement off of. So we're going to say 19, and that's going to be from here straight down. I'm going to select that line again and hit X to make it a construction line. I'm going to do the same thing up top. I hit L for line. I'm going to hit X for construction before I start my line. And now I'm just going to go straight up, but I'm going to go all the way to the top of that outside. That distance is 19 millimeters. Now, the amount of rotation that we have here, I do want to do one more line in construction mode. I want to go from this edge to this edge, and then I'm going to hit that with a horizontal. That just makes sure that I'm at the same angle on both sides. I can see as well that the edge right here is just at, or just below that flat. So I'm going to go with that as a visual for now. I do have a set of feeler gauges here. This is probably a little overkill, but I can check to see if I can just pull a thickness between these. That one feels about right. So about 5.5 or about 0.55 millimeters. Now, we do have a bit of a situation where you're stacking tolerances. You're measuring things, here, and then you're going off of that for the next thing, and you can just end up with a little bit of gap. While calipers are good for getting a good or decent measurement, they're not exactly that precise. They're not what you would use for high precision measuring, but for what we're doing here at this level, they're perfectly adequate. So now we're going to take and we're going to extrude that piece up by 2.82. And that gives us that part of it. Now, that is really the important part of what we needed to measure. That'll give us a pretty good fix on the radio side at this point. Now we need to get a rough idea of the model of the wheel so that we can base it there and then we can connect the dots. Sorry for the noisy cat. Now, from just taking the wheel and putting it on top of the radio, we knew that it could be pretty much right on top there. We're gonna wanna add a little bit of space, so we can do that quickly, but we're gonna take that, we're gonna keep that little piece of information in mind as we go forward. So I'm gonna pull the outside diameter of this wheel at 52.25. And before we put that onto this, we're gonna go hit construct, which will allow us to create a new plane, because rather than building right on that surface, like I said, we want to add a little bit of a gap. So we're going to select that surface, and then we're just going to go up 0.5 millimeters. So that created a new surface for us to touch, but it's just above the previous surface that we were working with. So now when we go to sketch, we're going to select that new plane instead. Now we're going to hit C for circle. We still have the origin to work off of since we've been doing that the whole time. And my measurement was again 52.25. And our inside diameter, we can pull a close estimate of 45 millimeters. And then we can extend that up all the way to that wheel face. I'm going to use a straight edge across the back. And I'm going to simplify this wheel and just go to the hub surface, which is at 13.35, but we're going to hit extrude. We're going to go up 13.35, but then we're going to subtract. So we're going to hit minus. I'm going to measure the thickness of this ruler, 0.75. So we're going to subtract 0.75, and that'll do the math for us automatically. So now we have the barrel of the wheel, which floats just over top of the face of the radio. I went to the actual mating face of the wheel just to simplify it. So we can do another sketch. We're just going to select that surface that we extruded up to, and we're going to do the inner bore, 12 millimeters, D for dimension, 12 millimeters. And then we have the 6-bolt pattern that is on there as well. Now, I already took the hub off, so I can just measure the hub, and we can just pull from center to center, or from edge to edge at 14.88. We can do a line with construction, and go from center to center, and then we can hit the triangle up top, and we can lock that line to the origin at the center. And that just means that this will always be the exact center on each side. So we're going to do 14.88. Now I measured that from the inside edge of each, so we need to add the diameter of one hole at 2.24, call it. So we're going to go plus 2.24. Now we can just do that 3 more times if we like. We can also put 2.24 on this. We can make both of these equal by clicking the equal sign up top and then selecting both circles. Now, like I said, we could do that 3 times, or we can do circular pattern, and you can select the objects that you want and the center point and just hit 3 and it will be done. Now, from here, we're going to hit extrude again, and we're going to select that face and this face, because we're going to bring that up by a distance that we're going to estimate as the thickness of the flange, 1.75 millimeters. Again, we are simplifying this wheel design just for this application. It can be a little bit hard to see items now since we're, have a bunch of stuff blocking. On the left side of your screen, you have the bodies drop down. We have two bodies that we've created. One is the wheel there, and the other is the radio. If you want to name them, it is helpful. You can type radio, and then you could double click and type wheel. Easy that way. And then if you want to toggle one off, you can just hit the I next to that model. So what we need to do now is we need to reverse engineer this shape on the back of the stock wheel, or at least in some simplified fashion. We can use it as kind of a sanity check as we go forward, making sure that everything is going to fit how we want. So that's going to be the easy way. We're trying to kind of take this piece and a hub and mash them together. The depth of this pocket in this wheel is 7.37 millimeters. So let's see how far down this it goes. If you remembered the dimension, that'd be great, but otherwise you can hit inspect, and then you can select from this face to here, and that was 7.8. So we leave about 0.4 millimeters of clearance before the bottom. So we're gonna hit a new sketch, and we're gonna select that top face. Now, you don't wanna make it exactly the size of the existing one, because that'll just be a very tight fit on there. It could be a problem. Working with tolerances, depending on how you're going to manufacture something, is important. For 3D printing, about 1/4 of a millimeter offset works pretty well. So now that we have this here, we can just type O for offset, and then click that line, and we're going to type 0.25. Now, that's pretty tight. Depending on how sure you are of your measurements, you can increase that or decrease that. If you wanted to go 0.3, 0.4, 0.5, might get a little loose on you because you're talking about 1 millimeter total, then you could have concerns. So 0.25 usually works pretty well. This flat that's on here basically goes straight across the center bore of this adapter. So we can take a line and just go straight across. We can hit the center constraint, click the line, and then click the origin. That'll lock it. Now it locks it, but the ends are still free. So we can still adjust the length because we have not put a constraint on that. This had a total width of 19.75 roughly. So we can do another circle if we want. Connect the dot, and then put a distance on that of 19.75. In this one, it's got a hollow center. Doesn't really matter for us. It's not a big deal. We do want to put the wall thickness around the other portion though, which is 1.3538 is technically what it measures. You can't offset an offset line already. So we're going to offset the existing or the original, and we're going to go 1.38 plus 0.25. You can tell that's getting right on top or interfering even with our original design. So we may be worried about those tolerances. Let's go to 1.4, and that should hopefully give us enough clearance where we don't have to worry about that. Again, I'm holding shift and then using the center click of my mouse to be able to kind of navigate around just to give myself a perspective of what we're looking at. E for extrude, and then we're going to select those planes there, 3.14. Now that went the wrong direction. So you can just go to the very beginning of that number and hit negative. That will go the opposite way. That gives us that. Now, we measured previously and saw that the actual engagement of the center hub, though, went quite a ways further down. And that's because I actually put this in the wrong spot. This should be all the way down because it interacts with these stops here. Now we can go back and adjust everything that we just did to be on a different plane and redraw it, but we really don't need to do that. The easiest way for us to do it is to move it. So you can hit M for move, and then you can select that, and then you can do a couple of different things. You can either do a center to center or point to point type change if you like. That's an easy one. Or you can do an even easier. We know how far down we can go, or we know that we're designing a new part and it doesn't really matter. So if you want to go down as far as it goes, pull it back up and give it some tolerance. add whatever you want. Negative 4.25 looks pretty decent. Let's go with that. Now let's complete the rest of the engagement of that center bore. New sketch, select the top. And now rather than redrawing everything that we did, you can hit P on your keyboard for project and select that face. And now hit OK. That gives you this purple outline to all of these items. We can do another circle and we can just connect that dot there. We're going to hit E for extrude again, select just that center part, and then click the upper, and it'll extrude that portion to the top. Hit OK, and now we have the start of our hub adapter. Now we do need a top on this. And this is where things can get tricky if you're not familiar with what you're doing. I'll explain and I'll show both ways how that happens. So we're going to hit Sketch. We're going to select on top of that plane. Now we need to do a clearance hole. So we're going to hit C for circle, select the center, and then do 3.1. Or you can even go to 3.25 just to give yourself a little bit extra space. And now what you would maybe think of doing is hitting E for extrude and selecting those profiles. And if you give yourself, say 2 millimeters as a round number. And now if you hit enter, it's going to create that. But what it's going to have done is joined the radio base and the new hub adapter that we created. On the left side, you can currently see there's 3 bodies: wheel, radio, wheel, and body 3. If I hit OK, body 3 or radio is going to go away. So hit that and the body went away. So body 3. I'm going to hit undo. And now I'm going to hit extrude again. There's a couple of ways that you could do this. So I'm going to select this. I'm going to go up 2 millimeters. Now I can either do one option, which is to turn off the radio base. And now if I hit OK, it will have joined that part to our hub adapter. And now I can turn the radio base back on and it is not connected any longer. I still have both bodies independently of each other. The other way that you can do that is I'm going to go down to the bottom feature tree and hit edit. And instead of join up here, I can hit new body and then hit OK. And now that is separate from all of the pieces. And you can see another part was created over here. Then you can hit combine at the top and you can select the original part and the top piece and hit OK. And now we've accomplished the same thing, but in a different way. Now, if you want to be able to visualize your parts a little bit easier, you can hit A for appearance, and then you can right-click, duplicate the materials, then hit right-click, edit, and then just change the color. Just drag around on that and hit done. Now, you can take that and just drag it onto a piece. That helps me a lot. I do that all of the time. If you ever see screenshots of my things, they're oftentimes multicolor, and that's just for easy visualization. If we turn the wheel back on, we're going to see that we have the hub coming through, and we need to connect the dots for the holes still. We can turn off the radio portion if we like, just to clear things up a little bit. And let's hit a sketch. Let's select the back side of the wheel. Let's hit C for circle. We're going to select the origin, drag out. Let's go to 24 millimeter. And then the hub screws on a Vanquish wheel like this are a 440 thread. But for this one, if you measure it, you'll get around 2.3. I'm going to use 2.4. And we're just going to select it, hit 2.4, and hit enter. When I modeled the actual wheel clearance, I modeled it based on the threaded hole size of the hub. So that's why you can see that those are actually very close and where they shouldn't be, but it's fine. Again, I'm going to do circular pattern. I'm going to select that. Then I'm going to hit center point in this menu, select the origin, and then I'm going to type 6 or hit the up button until that there is 6. And that will pattern those all around like I need. Now, another fun trick, rather than trying to go through and drawing up exactly how I need this to interact with this part, we can go to this create menu, go down to project/include, and go to intersect. The intersect menu will pop up, and now there's a face and there's a body. So we're going to select body, and then I'm going to select that hub. And it is going to create the lines that intersect with where my sketch plane is. It's just an easy way to get the geometry you need without having to go through all of the steps of recreating it or projecting it in a different way. So E for extrude again. We're going to select those, and then we're going to drag that down. Now at this point, we can drag that down, and we should be able to drag it down basically all the way to that face that we already created. Now, you see this red-gray thing? That is because we're having that same situation that we just did where we were combining bodies. So I am going to hit new body. You can see that that color change goes away. And now I'm going to hit OK. So if I turn the wheel off now and then I turn the radio back on, we can see visually if there's any interferences. And it looks like we're going to be pretty safe. So that's good news. Now we can hit the join. So we're going to hit combine, select the hub that we created, and then select that outside portion and hit OK. And those pieces are now one. Now, technically, that should be all we need to do. The only thing that bothers me a little bit is the style that we've got going on here. So I want to clean that up just a little bit by doing a new sketch on the face, hit C for circle. Then I'm going to get a little bit closer to the outside diameter of that wheel, hit D for diameter, select the outside diameter, or sorry, the inside diameter of that bore, and our new line, and I'm going to hit 0.25. And we're just going to take that down. I'm going to turn the wheel off, and we're just going to select that face to carry that bore straight down. And that gives us what should be an adapter for our wheel. The only thing I don't like still is that it isn't quite far enough up. I'd like it to come just a little bit more. We could extrude again. You could just hit E and select that face and decide how far you want to bring that up. It's an easy thing to do. Or there's also the push or press pull. So you can select that and select the face and just pull it as well. It's a very similar tool. It has different uses at different times, but it's something to think about. We're going to go up 1 millimeter. Now, just for fun, I'm going to hit modify chamfer, and I'm going to put about 0.5 millimeter of a chamfer on there, just because I think chamfers look good and help clean things up. I'm also going to put 0.25 millimeter chamfer on that inside hole. We're going to hide our wheel, hide the radio. This face here, I don't love how those things are intersecting. It's just kind of a funky look, and depending on the length of a screw, we are going to want to make sure we pay attention to that if they're going to intersect or interfere with anything as it actually assembles. So definitely something that's worth noting when you assemble things. Make sure your screws don't go too far. Being that this is basically done, there are a couple of other little things that you could do if you didn't love how those things were oriented, just because maybe you don't love how those are just intersecting with that. And we're going to come in and we're going to select all 6 of these holes. Then we're going to hit M for move. We're going to hit our center pivot by hit this button here, set pivot. We're going to come in and grab the center bore of the hub adapter. We're going to confirm that that's where we want. And then we can come in and I can just rotate these like 30 degrees. Now I hit OK. And now none of those intersect in that same spot. It's a small thing, but why not, right? Rather than create a sketch and do an extrude, you can just come in and select the bottom of those 3 holes and hit delete, and it'll punch them through as well. Simple trick, an easy one. And then these wall thicknesses, very thin. I'm going to do another sketch, and I'm just going to go 4 millimeters. And then I'm going to hit E for extrude, and I'm just going to add that surface there just to clean it up. F for fillet, because fillets make everything better. Then you can grab that arrow, just go to where you think it looks right. 5 millimeter, why not? And now that just gave us a little bit more strength around each of those screw holes. We don't have that weird intersection. simple stuff. Nothing wild and nothing to worry about now. And to 3D print this, all we do is we right click and we hit Save as Mesh. We're going to save this as, you can either do it as an STL or a 3MF. STL is easy. We're going to select that from the format and we're going to hit OK. Save it to wherever we plan. I'll put it on my downloads. That's fine. We'll 3D print it, test fit it, and we'll be done. The adapter is off of the printer now. Just do a quick test fit to make sure that everything looks like it lines up with the radio. And make sure that it looks like it lines up. Everything looks initially like it's going to be good to go. Let's actually assemble it on the wheel first just to make sure that none of our hardware issues are going to pop through. I had scale hardware on this wheel before, so I'm going to reinstall that with the special tool that it requires. Just about perfectly flush. The hub is bolted onto the wheel. See on the back side there? I think we've got room to tighten up the tolerance slightly on the center bore, but feels great. But I did put a foam on the outside of the wheel there, and we have a classed up Futaba 10PX. That is going to do it for our first edited version of STL Sunday, 3D Printing Sunday. I called it a lot of things in the past, but hopefully this gives us a basis to start this series back off on. And if you guys have any things that you would like to see done on here, absolutely drop them in the comments. Love to be able to tackle through a list of requests that you guys have. But if you have feedback on this series, things you would like to see done differently or improved, let me know. Love to hear it. Love to give this whole thing another shot. But that is going to do it for this video. Thank you again for watching, and we'll see you on the next one.